Hello, everyone. Thank you for joining us today. I hope that everyone can hear and see me clearly. Please let us know if something's wrong. Let's wait for just a second more for all of our attendees to join us.
Hello.
Hello, Dmitry. Okay, so thank you for joining us today once again. My name is Marina and I'm an event manager of IBA Group. Before we start, I would like to thank the Ministry of Economy and Sustainable Development of Georgia, as well as Georgia's Innovation and Technology Agency for their great help in organizing our webinar today. And before we start, I also would like to highlight some organizational moments. Firstly, please note that we are using Zoom platform, webinar mode. What does it mean? It means that you as attendees don't have access to a camera or to your microphone and cannot go live without a permission from a host who is me today. But still we have means for communication and interaction. Please look at the bottom of your screens. There you can see three buttons: chat, lower your hand, and Q&A button. If you want to ask a question, please type it using Q&A button, thus not chat. Thus, all of us will be sure that I won't miss your question and will read it during our Q&A sessions. If you want to ask a question in person, to go live, maybe using your microphone or maybe even camera, please let me know by raising your hand using lower raise your button, raise or lower your hand button. Okay, so when is the perfect moment to ask a question? Any moment is okay. If we are talking about using Q&A button, you can type question anyway, any moment you please during our Q&A sessions. After each presentation, we will make a small breaks and I will be reading your questions. If you want to ask a question in person, please raise your hand, but at the end of the webinar, so we can let go those who maybe want to go to return to their work on some important stuff. Okay, and before I introduce to you our first speaker, I would like to say a few words about our company, about IBA Group, who we are and what we do. We are a large international IT company. We have been operating on the market since 1993 for more than 27 years now. We are quite large. There are 2,800 of IT and business professionals of us today. We are widely spread geographically. The headquarters are located in Prague, and besides Czech Republic, we are presented in 11 countries. For our long history, we have implemented more than 2,000 projects for customers from 40 countries. And judging by the complexity of the projects implemented and of their number, we are most expertise at such industries as banking and finance, energy and utilities, government, transport, and manufacturing. Of course, as a continuously evolving company, we are watching IT world trends, and we are trying to implement best-in-class solutions and most perspective and innovative technologies in our projects and in our products. And today we want to talk about some of the solutions that are based on such modern technologies as digital twins, IoT, computer vision, but our purpose also is not only to share our thoughts and to present our solution, but also we are seeking for cooperation. Cooperation that will let us master our products and tailor them to the needs and requirements of your companies, your enterprise for the power sector of Georgia. Okay, now let me introduce to you our first speaker, Ruslan Bizmen. Ruslan has been with IBA Group for 17 years and it's quite a professional journey. And I don't want to give you a lot of details about his career, but still want to name a few facts. For these years, Ruslan has been engaged in many various projects in various fields from SAP to 3D, VR, and AR. He has a 2-year experience in IoT projects, and now he has a new technologies division, manages projects and specializes in challenging projects and tasks where there is no ready-to-use part-end solutions, and sometimes even no specially trained specialists. Okay, now I turn the floor to Ruslan. Ruslan, please.
Let me share my screen.
Mm-hmm.
Okay, do you see it now?
Yes.
Hello, my name is Ruslan Bezmen, and I'm going to introduce you IBA Technical High-Load IoT platform for remote monitoring and control. And let's not stop on the name and go to presentation directly. We will start with a small background. The fourth industrial revolution, or as well it is known as Industry 4.0, is the ongoing transformation of traditional manufacturing and industrial practice combined with the latest smart technology. Today, Industry 4.0 provides us new tasks to solve. And one of the biggest issues in manufacturing is the speed with which enterprise can provide service to machines, and especially in the case of failure. Second one is how enterprise can predict failures, even prevent failures. And third one, how enterprise can plan repairs and replacements with the shortest downtime. All these tasks require remote monitoring as initial point, and the enterprise should get full amount of data about operated equipment in a near real-time manner. It should be fast, precise, and at low cost if possible. But here we meet problems for remote industrial facilities. First of all, in many cases it is difficult to access remote equipment, and you cannot just drive every day to your equipment box somewhere in mountains, or you maybe will need helicopter. Even if it is accessible, it could be spread over a big area. Just imagine fields of solar stations, and it is not possible to check all equipments in a reasonable amount of time in this case. Another one possible case, it could be long. Also imagine how many resources you need to check state of international power lines or train rails. In some cases, equipment is very complex, or you have too many black boxes, so you need to check thousands of monitoring points. In other cases, you even do not have special power supply in place where you need to perform monitoring, so you cannot install your proven SCADA hardware. And in very special case, you even don't have any roads to reach your hardware, so helicopter again. All this lead us to only one way to cover these new Industry 4.0 challenges and provide good level of service. And this way is IoT technologies for remote monitoring and control. Next several slides represent kind of prehistory for our main presentation topic, IBA IoT platform. In IBA, we have special subdivision. It is Digital Twin Laboratory. It was created to deal with very different but usually innovative projects. On this slide, you can see several of them, projects related to main presentation topics. And let's see what we have here. First of all, it is agronomics, agriculture hardware and software solution. Next one is T-Rail. This is special complex system to control, predict, store, and analyze temperature of continuously welded rails. Also hardware and software solution, which main purpose is to prevent derailments. R-tube, another one solution which is used to monitor states of pipe isolation and structure of main water supply pipes. This is used to prevent water breakthrough in isolated pipes. Smart enterprise, this is digital twins of enterprise or building. And in our last case, we focused on our main office building to control air states, temperature, CO2, and to track personal movement. Planned digital twin concept. This is proof of concept project which show how we see front-end part of digital twin for big hardware system which generate multiple signals from different sources. And last one is a smart city. This is cockpit room for monitoring and controlling of city social services. All these projects are similar as they have one big feature, integrated IoT hardware and software. Let me quickly show simple IoT usage scenario based on two projects. I will talk only about hardware-software integration part, and we will leave machine learning and other modern technologies for another one presentation. First project is T-Rail. This is example of IoT project for remote controlling and monitoring of long industrial facilities integrated with a geo-information system. Just as example, we have rails here, but industrial power lines, also long industrial facilities located on some geo area. Thermal buckling is what we want to prevent here. What is thermal buckling? You can see on a picture. To prevent thermal buckling, you should know temperature of rails. And current solution, personnel just take manual temperature measurement device and go to several points of rails to measure and record temperature. Then worker just call focal point mobile and tell him the temperature. And please pay attention here. It call mobile and tell temperature even if he was too lazy to go and measure it. And second option, just to reduce speed limits for trains based on a weather forecast. Minus 20-30% just to be sure. And this is not too good from economic point of view. And here we come with IoT solution. We propose network of LoRaWAN base stations together with LoRaWAN modems which measure temperature automatically. It uses integrated battery with lifetime up to 10 years. Base station cover up to 15 kilometers radius area and about 10,000 devices per station. This is cheap, simple to use, precise, and fresh data for speed limit and repairs every day without any manual activity and without any lazy workers. Second project to use as example R2. Here is even nothing to explain, you can see everything on a picture. Main water supply system usually use pre-isolated pipes with a special control circuit integrated into isolation. With this control circuit and special hardware, it is possible to measure state of isolation, how far it is from breakthrough. And current solution is to measure all this manually, for many cases underground, or with old school GSM devices which could be installed only in the places where you have 230 volts power supply available. Here we come with IoT solution again. Depending on place where to install, we use NB IoT or LoRaWAN devices which collect information and alert about problems. These devices could be installed anywhere without any special power supply lines and into existing plugin interfaces. This is again simple, real-time, no any manual activity. We use different remote hardware for our projects. For example, complex meteor station, LoRaWAN base stations and modems of different manufacturers, NB-IoT and universal modems, smartphones of course, even handmade custom prototypes based on Arduino or STM32 controllers. If needed, we can use anything or develop new devices. Right part of this slide show you some of installed hardware, for example, testing of new LoRaWAN base station on the roof of our main office building. On this slide, you can see examples of software and platforms we use several years for our IoT projects. Of course, Amazon and Google IoT platforms also could be mentioned here. But it look like Zuo, which is used only to get data from devices to our IBA data center. So we decided to develop our own platform. It should be very comfortable, especially for developer who want to develop custom IoT projects for our customer. This means that we can provide very complex solution to our customer, not simple templatable solution. We support any needs of customer without any limitations and integrations problems which we usually see with any other software. And I'm talking about exactly IoT backend platform, not just another one clone of Amazon or Google software. Let's talk about main points of this solution. First of all, we focus on NB-IoT technologies. Platform also support many other technologies, including 3G, LoRaWAN, but NB-IoT is the most perspective one. It have low power consumptions, coverage equal to cellular network area, and main advantage, it will be one of narrowband 5G specification. So we will be able to migrate to 5G devices without any complex software upgrades. Second point of our solution, we use platform for all our new projects. So we do not need to deploy new zoo infrastructure for every new typical project. Next one point is one of our main, this is performance. For example, IBA IoT platform deployed with a simple default settings with cluster of two common cloud servers could collect, process, analyze, and archive more than 80 million messages per day. Let's see, to collect data from water pipes of a small city, you will need only middle-sized server with Zoo. But if you want to track, for example, power consumption of endpoint users in this city, you will need performance. So you will not be able to handle it with a simple server. And last point, it is stability, flexibility, and possibility to extend. Platform architecture allow us even to use it not in IoT projects, but for example, as backend for web portal. Stability allow to redeploy services or perform maintenance without any downtimes. So user never have out of service problems. Even if half of cluster servers will go down, platform will be active. And Lego pyramid is the best way to show this concept. So now it is possible to use all benefits of our IoT platform in any IoT projects for our customers, especially in a project where you need custom complex solution and not just templatable data transfer for equipment. As separate point, I would like to mention IBA Cloud Service icdc.io. We use it as best hosting for our platform, but it is possible to install it anywhere as on-premise solution. And by the way, we also could provide hardware part of solution. We can develop and produce devices on your needs. With described IoT platform, IBA could provide and deploy IoT solution for remote monitoring and control in very short terms with low effort and high efficiency. A new product and service creation is fast, it's easy to install it anywhere. It is possible to implement any complex projects having IBA IoT platform as backend. It is very flexible. It covers all possible devices and protocols with open architecture. We can integrate it with any other monitoring system or existing infrastructure, software and hardware. So you even can try to integrate your existing monitoring equipment with our IBA IoT platform. It is ready to use, have high performance, scalable, high availability platform. We can solve your remote monitoring and control tasks very fast to cover your Industry 4.0 challenges for your enterprise. And that's all. Thank you for your attention. Feel free to ask any questions.
Okay, thank you, Ruslan, very much. We have a question. Is it possible to launch a pilot project in Georgia?
Yes, we can launch it in Georgia. We can use our IBA cloud hosting for platform, or we can install this platform in Georgia servers and with hardware on endpoints in Georgia.
Okay, thank you. Is your platform available in any country?
Yes, of course, on-premise solution allow it to install in any country.
Okay, thank you. Any more questions? If you feel more comfortable, you can ask your questions in Russian or in English, as you want, as you please. Okay, one more question. Should I buy IoT equipment or you can provide it?
This depends on your need. You can buy your own IoT hardware, you can ask us to provide this hardware to manufacture for you, or you can request service without buying any hardware.
Okay, this is it probably for now, Ruslan. Thank you very much. And I would like you to meet our second speaker, Nick Vlasov. Nick joined our team 10 years ago, and he worked on IBM projects and projects related to process automation and machine learning. Now actively promotes and develops machine learning direction in our company and has a 3-year experience of work with computer vision technology. Nick believes that everything can be improved. The trick is to look at things and issues at a broader angle and keeping in mind evolving technologies. Okay, thank you, Nick. Please.
Okay, yep. Hello to everybody. So as you now know, my name is Nick. Today we'll speak about their electricity highlight defect highlighting tool. I will start sharing now, so it will be easier to see. Okay, and let's go on. So if we're speaking about their defects, and if we are speaking about the industrial defects, so that's always the thing which costs a lot. Each industry has its own infrastructure, and for most of industries, this infrastructure is pretty critical. This is a global problem for all the infrastructures all over the world, that it always there is not enough money to make an upgrades, to make a new infrastructure objects, or to rebuild and update it accordingly or just in advance. So we are developing the product now, which is focused on the defects in electricity, and we are speaking about their next problems. So these problems are valuable for electricity industry, but they are valuable actually for another industries as well. I will go back to the question about the other industries in the end of my presentation, and now we'll focus on the solution, which is, as example, exists now. So the first main problem is it's hard to get to the power lines. So sometimes the pylons can stand in the mountains or deep in the forests, where it's really unbelievably hard to get. You have to offer the special equipment, you have to order the helicopters. And for example, as example, this is in China, they are able to inspect only 2 pylons per day in the mountain places. The second problem, I don't say it's problem for now, but it's a fact. Its overhead power lines are too long. So we all know that the length of any infrastructure in industry usually lasts for thousands of kilometers, and 10,000 kilometers, or up to 100,000 kilometers and more. The next one is a human error. I don't want to blame on staff or some people who are working there, but the human error exists in any industry. The human error exists in IT and outside of IT, in electricity and in oil industry. And this is the thing which is really a problem, because if somebody has inspected the pylons and his only eyes has seen them. So it may be a problem in future because there is no possibility to understand what was the state. And if the person did an error or he hasn't seen something, so that will be a great disaster. The limited angle of view with human maintenance. That's the problem where the people are just doing the maintenance manually. They go to the place, they walk around the pylons, they work over the lines, they look at them with the binoculars, and the angle they see differs much from the one which drone can offer, or some other equipment which is put on the top of the pylons. The major focus to the high voltage OPLs. Actually, this is for the post-Soviet Union countries. This is a major focus on the high voltage. And when we talk about the mid voltage or low voltage, everybody says, yeah, we need to inspect it as well as a high voltage, but the investments are less than expected, and so we are not able to go there with the current situation. Actually, that's clear, understandable. To the high voltage OPL's length is high, and the mid voltage OPL's length is much higher. So that's clear, and that's a kind of a problem. During the work and the discovery in our local environment, the post-Soviet Union countries, we have found a few more defects. I call them defects now, but that's a kind of a problems which people in this industry face with. So actually the data centralization is missing. That was a surprise for me, that the data centralization is now built as a notebook, and you can put some notes there, and there is no assignment of the photos of the defects they have found, and there is no any proofs regarding what was found, just some text and handwriting. I'm not sure that this situation is similar for Georgia or similar for other countries, but this is a kind of a told problem, and we're in our system we are trying to cope with this problem as well. No easy access to defects for historical data. So let's imagine something happens on the infrastructure, on the power lines, and it's just an option. Hey, let's see how it was a month ago when we did an inspection. Maybe we have missed something. So there is no option to learn. There is no option to improve the maintenance, or even to do a kind of a lessons learned for the people who are working there. Lots of paperwork. So that's a kind of typical problem. And that's why we're doing the digital transformation all over the sites now, and all industries are trying to do this transformation. So I don't think that I should tell a lot here. Routine review in the inspections video. So the companies who does inspections currently with the drones, they can watch directly there what was the problem, or in advance, or instead they can review the videos when they come back to office, and that takes lots of time. So I will try to escape from showing you the menus and the system by itself. I will show you the major steps so you can understand how this all works. If you will be interested in the system by itself or in pilot, then we will have the extra one presentation. The first step is you are taking the video, photos, videos from any sources. So we have an example, the drones, and this may go from any source. Cameras, like small drones, helicopters, anywhere where you can find it. So here we can see the angles which drones can provide. I think that it's not in use for you about the drones itself. So the next step of the system is the data upload. So it's a kind of as simple as a Google Drive. You just drag and drop there the files, and the system starts to upload in them. We have an option when you can upload it within setting the objects directly, so that can be a bit different. And the major part here is AI processing. So that's a main magic box which lots of people think that it's a kind of the box which does some interesting stuff. We should understand that the computer vision and machine learning are not the magic boxes. They are each part is doing its own job. For example, here there's a neural network which is detecting the objects only, so it does not find the defects. It's just finding the objects on the picture. There is actually not a big data set here built. It's around 200 or 500 photos. So we have to understand that the data sets should be up to 10,000. We have them, but as example, I always put the small data set result. Here we can see how we detect the wires. And thus again, the wires are widely used now in our algorithms to see the vegetable growth and to detect the danger vegetable growth here. The next one step usually is a post-processing, it's called. So for those who like photos or who do photos, you should know that the negative and black and white transformation usually does some extra results in the contrast. So now we can see how easily we can detect the sky and the forest on the background. On the right page, it's just a black and white, and on the left, to me, maybe you understand. So it's a negative transformation. So this is an example of how the steps does work. And here is one more example before we will jump to the defects. It's edge and height analysis. So the edge analysis is usually done in our system for taking the rust on the objects. So you can see the edge in red. And this is can be widely used for analyzing the systems for the object stability and for the object for the construction strength. So if something is broken or something is going to be broken, so it can be detected as well. And the high analysis. So this kindly, honestly speaking, it's usually done with a LiDAR in all over the world, but we all understand that the price of LiDAR is too high, and before getting to the LiDAR, you have to get a proof of that the solution works. So not far ago, we did a great solution in our system which allows you to detect the dangerous vegetable growth without the LiDAR, just on the videos. For sure, it will not be as detailed and as correct as a LiDAR one, but it does a result, and you can have highlights where there are dangerous trees or the dangerous plants under the power lines. And here's an example of some processes, some final result that the system is finding the defects in concrete tower. So it's pretty hard not to find this defect for sure, but as a good example, it can be put here. And the second one is a detection which is done by the system regarding the vegetable growth. So as personally me now on this picture, it's very hard for me even to see the wires. I'm not saying about to understand where is the dangerous vegetable growth. So that's a kind of our proud here that we've been fighting with it for a couple of months, 3 or 4 months to invent this algorithm. And finally it works, and we are planning to improve it much in future. So this is regarding the AI processing and the main part of the system. And finally in the system, it exists possibility to build the report. I don't say again that it's needful for you or for your company. So we're now rebuilding a bit the solution just to let us see defects on the files. And if you will need, you can create the report, print, save, or send it via email to your manager, or to not your manager, but to the manager who are responsible for this, or just to the person who is responsible for this, for the collection of this data. As an extra, there is a possibility to build the kind of technology which will connect to some database and will post the defects there. So if it's a very high-tech company, so that can be built. I will briefly jump to the product's benefits. they improve maintenance results for sure. But the vegetable growth, you can analyze it. Even you can just upload the videos after the inspections you do with drones, and it will add some information for you just without your control or without your activity. The human error minimization. So the system is going to grow. The system is improving now. We have did a great result in building the data without taking the data directly from you. So you know that it's very hard sometimes to find some rare industrial defects. So now we have an algorithm which can simulate this, and we can build the data sets to do it. So actually, to build the defects, we need at least some 3-5 photos where you will show us that how does it look like. The hard to reach places inspections go simple. Yeah, that's really go simple. Currently, there are some of companies use helicopters or the very high price equipment, the transport, which goes there and checks and brings people there. And it's not needed with drones inspections and with our system of the processing. The system solves high cost map creation tasks. So if you're interested in creation in the kind of cartography task or creation the map of your objects, especially the low mid, if you will need it, the system may build the map, and you may use the coordinates as you want, and we can extract it and give it to you. So you will have a map of the coordinate with the coordinate with GPS coordinates of your objects. So what I told, I go back to the areas we can be used. So that electricity energy is an example of this system, and we are focusing mostly on finding and solving and highlighting the industrial defects by our solution. So the system can be adopted to the areas of oil and gas, to the agriculture, even to nuclear industry. It's pretty similar to electricity regarding the big buildings which can be reviewed, and the pipelines as well. And for oil and gas, there are some infrastructure objects and which should be monitored and which can be monitored, and which is now monitored by visual inspections manually. So the area of our solution is much wider. And if you have objects, even if it's static cameras, even if it's some special kind of cameras, we are focusing on finding defects and dangerous situation in industries, in different industries. So you see 5 examples here, but I told you if there is infrastructure, if there is some video monitoring, you can go ahead and ask us about how we can adopt and how fast we can start the pilot there. Okay, so I'm really sorry if I jumped out of the time a bit because I haven't seen, oh no, that's fine. I haven't seen the timer. So it's kind of my contact in QR. If you will use your mobile phone, you can add my contact and just ask me the questions after the presentation, or get into the contact with me, so to discuss any options. And I'm really fine now to answer the questions briefly, not to take extra time here. Thank you, everybody. So yeah, that was me. So the questions.
Okay, Nick, thank you very much. I have noted that we have a raised hand from Georgie. I will let you into our conversation if you still have a question. Please go ahead. You can to unmute yourself and ask your question in person, or maybe you just press the button by mistake. Georgie? Okay, maybe it was by mistake.
Mm-hmm.
Yeah. Or maybe not.
Hello, everybody. It was very interesting for.
Hello?
Hello, can you hear me?
Yes, we hear you pretty well. Thank you.
Hello. First presentation and second presentation both was very interesting. Besides this short term of presentation, regarding regarding these drones and defect detection systems. It's very interesting, your experience and your practice. And I hope after this all presentation, you will provide us this material stuffs to read and to analyze this all documents. And I think after this reading and assumption, we will have some questions, and we will direct you regarding questions.
Okay, thank you very much for feedback. Okay, we will surely provide you with video and with all the documents, presentations, all we need. Okay, we have, I think we had one more raised hand, but I think it was from Nino.
Hello, do you hear me?
Yes, hi.
Hi, I just joined the presentation a little bit late, but it was very interesting, and I would like to say the same thing as Georgi. If you could send us the documentation, the electronic version of your presentation, we will be able to send you questions then in written. Okay?
Okay, thank you very much. Of course, we will definitely do. Okay, we have a few more questions regarding drones and computer vision technology. So how can we use this technology on Georgian railway?
Yes, that's a kind of good example. So in the Georgian Railway, this technology can be used as example of the wire defects detection system. So it can be put to the train with the camera and some sensor, and the data will be uploaded from these sensors, and the power lines as well can be detected, and it can be like a very useful item to find the defects on its own while the trains are going through their roads, and the system is working in background, I would say. So the defects of their wires can be catched, and if there is a kind of a possibility or need to detect some dangerous situations in the surrounding of the railway stations or on the places where the trains the trains are parked. So using the static cameras, we can detect any areas where the people should not go or which are dangerous, and see when and why the lines were crossed. So that's a kind of a few examples of the computer vision use in the railway stations, as I know for now.
Okay, thank you. One more question. Is your solution already used by any company?
Yes, for sure. So we are now working with a pilot in a test mode with our local company, with our Brest Energy company. This is a kind of a part of our monopolist of electricity in country, and we're now in a test mode working with them. So they're actually, for sure, there is an infrastructure questions now from the Brest Energy, so they have to do like a bit faster their Ethernet infrastructure, because our system requires at least like 2 to 4 megabit. It's not very big, but for some reasons there is a lower bandwidth in the Brest Energy, and we are working now with them. Yes, so and finding out the way to do another pilots in different countries, and especially in Georgia now.
Okay, thank you very much. And one more question: do we need to have drones, or you provide the whole service?
Okay, so regarding the drones and the service, so our system differs from the systems which are provided within the drone and software. because we does not want our clients to be dependent on us with the drones itself, with the hardware solution, because hardware goes fast, very, very, very fast, I would say, and it updates all the time. And our system is focused on the data processing, and it does not care where from you give this video to it. So if you have drones, that's fine. If you don't have drones or you want to buy, we can assist you with what kind of drone to buy. We can assist you up to finally to the companies which you can buy, or just with equipment. If you're not interested in buying the drones as well, there are a lot of companies which provide the local inspections with the drones, and they can do this inspection and upload the data to our system. So that will be kind of a wider value proposition for you. And here we will assist you for sure with finding these companies and with working with them. So you will not need to worry about this.
Okay, thank you very much. And I see still that Georgie raised his hand. Is it by mistake, or maybe you want to add something? Please unmute yourself and ask a question. Okay, maybe Georgie forgot to lower his hand. Okay, now thank you very much, Nick. Let's turn the phone to our third speaker. Our third speaker is Alexey. Alexey has been with us since 2007. It's also quite a journey in terms of professional life, and he gained diverse experience in numerous projects and took part in the development of Chancellor, which is our proprietary product and e-document system. Now Alexey manages projects and people within his work at Digital Twin Laboratory at IBA Group. He actively promotes the idea of the development of our own products based on digital twin technology, but today he's going to tell us about an interesting solution from our partner. Alexey, please.
Thank you, Marina. Let me share my screen. I hope everyone can see the presentation. Hello, everyone. I'm Alexey Sachok. Today, I am going to introduce you to the product CIMIT simulation software from our partner Siemens. This product attracts our attention, but is wide range capabilities in creating simulation model and the enterprise simulators. Our organization has already trained personnel for making usage of this product capabilities, and today we are in searching a customer to start pilot project. Let's begin. We start with purpose and benefits. Almost every industry faces the following three challenges: increasing pressure in terms of project deadlines, need to greater plant profitability, and lack of highly qualified personnel. A real-time simulation of automation project has proven to be very efficient for these requirements. With CIMIT, you can perform simulation on a single platform, which permits comprehensive tests of automation project, as well as the virtual commission of system machineries and processes. In addition, the simulation platform can also be used for creating a realistic training environment for operational personnel. They use CIMIT. We create a simulation model of your machineries or plants and to lay the foundation for the digital twin as a virtual representation of your technology reality. Using simulation software, you can reduce different risk, cost, time to market, improve quality and performance. What are benefits from virtual commission with CIMIT? With CIMIT, we simulate all relevant automation function can be tested safely and efficiently before the actual startup using the original automation programs. Virtual model helps us create and customize application software, identify early errors, test various hypotheses and different optimization solutions, and select the best ones. Therefore, we can more accurately predict the cost, human resource, and spare parts needed to start a real commission. Now consider benefits of real models, of simulation models for operation training. In some industry, for example, in hazardous ones, deep practical knowledge cannot be obtained due to the existing danger for personnel, equipment, or environment, or due to law prohibiting the usage of real machines and equipment for training. But with CIMIT, it is possible because operators can be trained on a simulation model, and additional operator teams can be trained before the actual startup of the plant. The use of simulation provides for diving effects in the learning process, which helps to quickly train qualified personnel. Because we don't need to use real equipment, we can organize distance learning for personnel. And additional, it is possible to check the usability of operator's interface at the design phase or test the interface software for errors are available. Let's look at the real world and the virtual world with CIMIT in the context of continuous production. The real world is represented on the left. Consider it top from bottom. The top level is the user interface. The next is the automation system or controllers. Then comes periphery, remote input-output devices, actuators, sensors, and the bottom other technology behavior. The virtual world is located on the right. You can see that the top level has not changed, but starting from automation system level, you can see some changes. It means that from this level, it's possible to build a simulation model using CIMIT with or without additional software or hardware. Let's take a closer look at the simulation part of virtual world. Consider the top level. There are two available concepts for a plant simulation. The first is hardware in the loop, shown at the top right. It is a combination of real automation hardware and a simulation of components and physical processes. At the second, so-called software in the loop, shown at the left top, in additional to the assemblies and physical process, the software in the loop concept completely replace the real automation hardware with software and simulated. For this implementation, virtual controller is integrated into CIMIT. Virtual controller simulate a station with process image input and output and was specially designed for virtual commission and operation training. I know two advantages of the CIMIT when simulation occurs without a real automation system or without real controllers and other hardware. The first is the ability to control the simulation time. For example, slow down, speed up. Slow simulation helps catch errors in fast processes. And the second advantage is snapshot. It is a functionality CIMIT for store current virtual controller and simulation model state. This allows you to start simulation from a certain start point. And consider the next levels and possibilities. CIMIT supports various options for importing existing data from different engineering systems, and this greatly facilitates the work on creating a simulation model. Data about signal sensor machineries can be easily imported from Siemens application, such as PCS7 or COMOS application, and also from third-party application by the Excel or XML file, or using a specialized functional mockup interface. CIMIT already has extensive libraries with ready-to-use components for any devices, and some specialized libraries for simulation conveyor lines or pipeline network. Of course, use of some libraries is limited by their specific. It can also be said that each system is unique, and we can not find the requirement component in existing libraries or templates. For such cases, the CIMIT has component editor, is functionality for creating new component or editing existing components from libraries, programming its behavior and visualization. Since CIMIT supports various couplings, so this allows you to connect and synchronize it with other software. For example, in case when an enterprise already has specialized simulators, CIMIT can collaborate with that simulator. You can see a schematic connection at the bottom of the slide. As an example, CIMIT describes behavior of equipment in general, and a specialized simulator is used to simulate deep chemical process inside this equipment. All this allows you to create any simulation model with different logic and 2D visualization and apply these models in any industry. This slide shows two examples of technology behavior without any couplings, because this is demos, so that you can imagine a CIMIT simulation model. The CIMIT example is state reactor using, the left example is state reactor using the ChemBasic library. On screen, you can see the following components such as tanks, valves, pumps, heat exchanging, measure points, etc. And the right example describes the behavior of a soft drink packaging conveyor line. CIMIT simulation models allows you to change various values and parameters and see how system respond to it. Also in CIMIT, there is a functionality for tracking values or parameters for a simulation model. As you can see, that in CIMIT, the logic and elements are visualized, which allows you to easily understand it. Programming logic or visualization can be released by the programming language C# in CIMIT component editor. But in the CIMIT projects themselves, there are already compiled objects as blocks or diagrams, which you can add to schemes by simple dragging and dropping. Now I will give you an example of its possible use CIMIT in an energy sector. For example, for hydroelectric power station, you can simulate the behavior of turbine, control valves, and flows of a driving turbine, and use this model for train operators or for test and optimization solution. All we need to create a simulation model is an understanding of ongoing processes, and to do this, you can use the process characteristic, technical documentation, and historical data. A few words about licenses. There are 4 licenses variants for CIMIT. There are SML, XL packages, All packages have the same functionality, but differ in project size. For example, usually package is used to simulate machines, M lines, L for PC7 projects, and Excel for creating operation training simulator. The license provided by one physical dongle key, and it is available to all computers on the network. Licensing is flexible and allows for conversion package. I note that IBA has an agreement with Siemens to provide a free temporary license key for our project. Perhaps that's all. In conclusion, let me sum up and mention the main point. CIMIT is simulation platform with existing extensive functionality for automation project and allows you to create a foundation for a digital twin. CIMIT is flexible software because of its extensive functionality and possible to expand it. We can create any mathematical model with different couplings for exchange data, simulate controller, and therefore create simulation model of any device, machineries, and processes for any industry. CIMIT allows you to collaborate with Siemens and also with third-party software and hardware. CIMIT is friendly software. Existing or creating components are represented as blocks or diagrams that are easy to use and understand. Well, I am covered the point that I need to present today. Thank you for your attention, and now I will be happy to answer any question. Sorry.
Okay, thank you very much. Please, if you have any questions, you can ask by raising your hand or the Q&A button, please. And in meanwhile, I will start a small poll. Please take a moment to participate. Your feedback is really important to us. Thank you very much. Any questions? Okay. Question: what are the steps to implement CIMIT in the enterprise?
Okay, on the step, we start the project, we need to a contact person from the side of enterprise. For example, contact with chief engineer who can describe the processes, and also we need to technical documentation. And of course, to contact with representative of our sales center, I think Sergey Molchanov or Ivan Sukman, and discuss the condition for start.
Okay, thank you very much. Okay, once again, thank you very much for joining us at our webinar. Let's cooperate. We are ready to launch pilot projects. We're ready to host individual online presentations. Please leave your request at our site. And of course, we will send all the information, presentations, documents, and video of our webinar to all the attendees. So, if there is no more questions, then probably we can say goodbye to each other. Right? Thank you very much for your attention. Thank you to our panelists. And goodbye.
Thank you. Thank you very much.
Thank you. Goodbye.
Thank you. Bye.